So this is a math class, so let's talk about the mathematics of districts and voters. One important thing is that each district in the state should include the same number of people. To guarantee a win in a district, a candidate needs a majority of votes. Now, technically, depending on the rules in a state, a candidate doesn't necessarily need a majority. They maybe need a plurality. But what we want to do for the purposes of gerrymandering is that when we draw districts, we want to try to guarantee a win in a district. And a majority is a great way to guarantee it, okay? Plurality is it's hard to judge whether that will really guarantee a win, but majority, you can be assured you're going to get the win. So usually when we do these calculations, we want to think about majorities. Let's look at an example. Say a state has 2 million people in 8 districts. The party affiliations in the state are 50% Republican and 50% Democrat. And we're going to assume for simplicity that all people in the state vote. And we know that's not exactly accurate. You have kids that aren't voting. You have to be over 18 or over to vote. But just for simplicity's sake, let's just assume everybody votes. So how many people are in each district? Well, there's 2 million people in the state. And remember, it has to be evenly split among the districts. So 2 million people evenly split means we're going to divide by 8 districts. So 2 million divided by 8 districts is 250,000 people per district. So we've got 250,000 people in every single district. Now, how many votes does a candidate need to win a district? Well, remember, you need a majority. And a majority is just over half. So a good way to find the majority is to look at 250,000 and divide it by 2, so go to half, but then we need more than a half, so add 1 is a good way to just get over the 50% line. So if we do that, that would be 125,001 votes. 125,000 for half, and then we need 1 more. So we would need at least this many votes to get a majority. Now you could have more, but we need at least this many. So at least 125,001 votes. So that would be if we're trying to make sure we guarantee a win, we need at least this many votes in a particular district. Now, how many Republican voters and Democratic voters are in the state? Well, it said earlier that there was 50% Republicans and 50% Democrats. And if there's 2 million people, 50-50 is splitting it exactly in half. So there would be 1 million Republican voters. I'll abbreviate Republican there, and 1 million Democratic voters. Now, 50-50 is pretty easy to split in this way. If you had a more complicated percent, even just 40-60, the way you can calculate how many voters will be Republicans, if say there's 40 Republicans, is you just simply multiply 40% times 2 million. So the total number of people. So it's still pretty easy to get to, and we'll look at other examples like that later on. Now, if the district boundaries are drawn such that the number of seats won by the parties were proportional to party affiliations, so the same proportions or same percentages as party affiliations, how many seats would go to each party? Well, remember, we're talking about 50-50, and if there's 8 districts and we wanted to split those up 50-50, that means half would go to so 4 seats would go to the Democrats, and half would go to Republicans, so 4 seats to Republicans. So half and half, 4 and 4, split it evenly. So that's if things were proportional to party affiliation. Well, let's look at what we could do if we wanted to manipulate the numbers with gerrymandering. So say we wanted to gerrymander with this last example. Remember, the state has 2 million people in 8 districts. There are 250,000 people in each district. Party affiliations are 50% Democrat, 50% Republican. Say the Republicans drawing the maps, so they're in charge of the state legislature, and they decide to draw District 1, so that it's composed entirely of Democratic voters. So remember, there's 250 people in a district, so if it has entirely Democratic voters, District 1, all 250,000 people would be Democrats, and there would be 0 Republicans. Okay, so that's going to be the Republicans' first step. They're going to basically pack District 1 with 250,000 Democrats. Now, let's investigate the other districts. How many Democratic voters and Republican voters are left to go into the other districts? Now, there's 7 districts left. So, if you think about the Democratic voters that are left, there were 1 million to start with, but we went ahead and put 250,000 into the first district. So that means there are 750,000 Democratic voters left. And then we also have all of the Republicans left, 1 million of them altogether, because none of them went into the first district. So 1 million Republican votes. All right, so now let's work with these two numbers, the Democrats and the Republicans that are left. And let's say the remaining 7 districts, because remember we've done 1 district out of the 8, so the remaining 7 are drawn such that the Democrat and Republican voters are evenly split amongst those 7 districts. How many Democratic and Republican votes would be in each? Well, I would take that 750,000 Democrats and I would divide them by 7 districts. So each district, 2 through 8, would have, if I divide by 7, 107,143, and I did round Democrats there. So I just rounded to make it easier to a whole number of people. 107,143. And then I do the same thing for the Republicans. I take 1 million Republicans and I divide by 7. So each of those new districts, or the remaining 7 districts, would have 142,857 Republicans. So each of my new districts, my 7 districts here, would have 107,000 Democrats approximately and 143,000 Republicans approximately. I just rounding there. So think about what would happen in future elections based on having District 1 with all Democrats and District 2 through 8 having 107,000 Democrats and about 143,000 Republicans. Well, District 1 would definitely go to the Democrats, so you would have 1 Democratic seat. And then all 7 of the other districts have more Republicans in them, so all of the remaining 7 would be Republican seats. So remember how we said if things were drawn up proportionally, if the seats were won proportional to party affiliations, then it would go 4 and 4. But with gerrymandering, and this was a pretty straightforward process, we were able to manipulate the numbers such that only 1 Democrat wins and 7 Republicans win, which is way off from 4 and 4. So just some real simple numbers, and basically it came down to 2 things that the Republicans did, and this could be done by either party, but I had the Republicans drawing the map here. What they did is they packed their opponents into 1 district. So they packed 1 district with their opponents. And then what they did is that allowed them to weaken or crack the other districts, crack their remaining votes into the other districts, so the Republicans had the power in the remaining districts. This is a standard practice called pack and crack. You pack 1 or maybe 2 districts with your opponents in order to weaken them in the rest so you can win the rest. And it's a pretty straightforward process. There were no hard calculations here. It was just a matter of putting a lot of Democrats into 1 to weaken them in the rest of the districts.